All right, good afternoon or good morning, depends on where you are. It's come to our next session. Our session speaker is Kieran Miller. Kieran is the chief architect at Garantir, a cybersecurity company based in San Diego, California. Before joining Garantir, Kieran spent more than 10 years working in cybersecurity, including 80 years with Leidos, a major defense contractor, and several years with Gemalto, which was later acquired by Thales. A lot of company names, I have to pronounce that correctly. And Kieran will talk about a new approach to centrally managing digital identities, which is a very important and interesting topic. Now, let me hand over to Kieran. Kieran, all yours.
Thanks, Brian. Pleasure to be here. Thanks for having me. I know my former workplaces didn't have the easiest names to pronounce, but we're excited to talk today about a centralized approach to managing digital identities that's more encompassing than just web applications. And it also has a nice byproduct of being able to apply more advanced security controls, such as multi-factor authentication, just-in-time access, that sort of stuff, to a broader range of resources without requiring custom code. So let's take a look at how that works. So as I said, we're Garantir. We're focused in this space, and really, when we look at an enterprise identity system, this is what it looks like. You have an end user who authenticates to an identity provider, Active Directory, Azure, Okta, there are some others. And then those provide single sign-on to downstream resources, typically via Kerberos, SAML, or OpenID Connect. And so this is a pretty common pattern. Now, it's not inherent in the architecture, but there's some limitations, at least in how it's been deployed today. One of the main limitations is the fact that we haven't really applied this across the globe to all resources. We've done a really good job of applying it to web applications, some file servers. But for example, what about things like downloaded resources? So what do we mean by that? Files that I've already downloaded. Let's say I'm an employee who's working remotely and I've already downloaded some files, and then later on I change roles within the company, or I even leave the company. Can you stop me from accessing those downloaded resources right at the moment when I leave the company? That's especially challenging to do when employees are remote and you can no longer just immediately revoke their laptop. Other systems like source code repositories, code signing systems, a lot of times we'll see identity that's not really federated applied to those resources. And then even things like accessing production servers via SSH. So it's not that we can't apply those other forms of federated access to these systems. It's just that it's challenging and it's time consuming. And then furthermore, we have this challenge that enforcing these other security controls like multi-factor authentication will typically end up requiring custom code or third-party security software. Now, some of these third-party security software have done a great job of saying one line of code, 2 lines of code to enforce security controls. And that's great. But 1 line or 2 lines of code starts to add up when you have 1,000 resources across the enterprise. And you have to do all the testing to make sure the deployment is successful. And it may require downtime on the resource. It starts to grow pretty linearly, pretty quickly. So what do we want the ideal enterprise identity system to look like? It's pretty similar to the previous diagram. You have the end user who authenticates with whatever granular security controls you'd like to the identity system, where you have the centralized auditing and administration that you always do. And that's applied to all resources within the enterprise. That's really what we want. We want to encompass all the resources in the enterprise, and we want to be able to apply the granular security controls sort of centrally and not affect the downstream resources when we want to add additional security controls. So let's just quickly talk, what do we mean by granular security controls? Everyone knows about multi-factor authentication, whether those are TOTP codes, FIDO2, whatever they are, multi-factor authentication is pretty commonly known. Device authentication, that's becoming more popular. So that's in addition to authenticating the end user, we want to authenticate the device that the end user is using. So for example, again, very important in the remote world, but even on-premise, let's say your end user, you want to say, all right, my employees are allowed to access their email from any laptop as long as they successfully authenticate, but they're not allowed to SSH to the production servers using anything but their work issued laptop. Then using device authentication, you can tell which device are they using, and then say, can that employee use that device, and do further security checks. Just-in-time access, that's another one that's gaining in popularity. So perhaps I'm allowed to, as a sysadmin, I'm allowed to access production servers, but that doesn't mean I should be able to access them anytime that I want. I should only be able to access them when there's a need to do so. For example, a ticket request is approved that says we need to make a change to the production server. The other ones are fairly self-explanatory. Notifications, very detective control, approval workflows to, a quorum of approvers having to approve that I'm allowed to access a system, et cetera. So these are the granular security controls today. Tomorrow they may change, but the point is, whatever the controls are, we want to be able to add them in without affecting the downstream resources, without having to add new lines of code, and without having this linear sort of deployment time and effort to deploy them. So what are some challenges with common techniques used today? So what I was talking about earlier, enforcing these granular controls, it requires new software typically. So whether that's 1 or 2 lines of code, a PAM module onto a server, that kind of thing. Sometimes you don't even have access to the system. It's managed by a third party. Maybe it's a SaaS solution or something, and you don't have control over it. And so you have a mandate to enforce multi-factor authentication, but your third party says we're not going to get to that for another 2 quarters, and therein lies the challenge. So how do you do it then? And then, of course, the specific case of locally stored files. So content I've already downloaded. How do you apply identity to that at all after the content's already been downloaded? So what we're proposing is a simpler approach. So right now, a lot of these controls are applied at the application layer. So it's very specific to each application, whatever that application is. And we go in and we sort of linearly push the controls out to each of these systems. We integrate each of these systems with our identity system, and that's how we get it to work. What we're proposing is to actually do it at the transport or session layer, and then be able to have the downstream resources be sort of left agnostic or unchanged because of the way we did this. Now, we're able to do this because the protocols and use cases, they all support key-based access, right? So remote desktop, SSH, mutual TLS, that they all have some form of key-based access that you can use. Now, normally when you do key-based access, we use it a lot, right? SSH is a very common one to use key-based access today. But the problem is most people do it where the end user who is going to access the system, they just have the key locally on their system, or at the end of the day, they get the key locally to their system. What we're proposing is to actually take those keys that are used to access those resources, manage them centrally in some form of key management system. There's a lot of names for it, but some form of secured key management system, and have that key management system actually enforce the granular security controls. And then the downstream resources don't even know that those security controls were enforced, but they still were. So they remain unchanged. The key management system is doing that enforcement, and the key management system integrates with the identity system. So all in all, it looks like this. This is maybe a little bit to take in, but you have the end user there on the left who is trying to access the enterprise resources, which are on the bottom. And the end user will then authenticate to the identity provider, whichever one is used in your environment, use whatever form of authentication method, And then the orchestration platform or the key management system will enforce whatever additional security controls need to be done at that time to use the particular key to access the resource. All right, so, and this applies again across the board to SSH, remote desktop, etc. So what does this actually look like, right? So obviously it sounds like a lot's going on, and there is a lot going on underneath the hood, but really the point is to make it backwards compatible with existing infrastructure without requiring a lot of changes. So there's two scenarios we're going to show. So the first one is I want to remotely access a system like a Linux server or a web application. So we're going to show SSH and a mutual TLS authentication. And we're going to show enforcing just-in-time access as well as multi-factor authentication for both use cases. And in both cases, we are not going to have installed anything on the target system. So the web application is going to remain unchanged. The Linux server is not going to have a PAM module or anything installed on it. Nothing is dynamically changing the Linux server in any way. And so let's take a look at what that looks like. So we're showing the key that we're going to authenticate via SSH with. So the first time we'll just do a normal authentication and it should succeed. And there we go. We were successfully able to authenticate. So now to show just-in-time access, we're going to disable that key, not change anything on the Linux server. And now when we go to authenticate, it should fail because the key is disabled and we can't use it. And by doing that, we've already shown how you can do just-in-time access. You can keep the key disabled and then only enable it when there's a time to use it. Now we can go further than that. Once you proxy access to the key, you can enforce policy. You see the key policy change there to enforce multi-factor authentication. So this time when we go in to authenticate, you'll notice something popped up in the background and we're prompted to complete multi-factor authentication. In this case, we're using TOTP codes for multi-factor, but it doesn't have to be TOTP. And then now you'll see the authentication completes. And that was all done without modifying the target Linux system. So you're going to see the exact same thing done for a web application here. So we're using a client authentication key to do a mutual TLS to a web application. So same idea. The first time it'll successfully authenticate. And you'll see there it is, the certificate name is printed to the web application. So now this time we're going to go ahead and disable that key. And again, it should fail. So this is the just-in-time access. So again, this would be keep the key disabled by default and only enable it when there's a time to use it. So here we go. There'll be a failure because we can't use the key. There we go, error. It says the client auth signature failed. And then now we're going to go ahead and enable the key again. And then we're going to change the policy to enforce multi-factor authentication. And again, this is without modifying the web application at all. And we are going to be able to enforce multi-factor authentication on the web app while it stays unchanged. So there we go. We're prompted to enter the multi-factor authentication credentials, again, using TOTP this time. You could easily add, FIDO2 WebAuthn here as well. And we should see, there we go. We've authenticated to the web application using multi-factor authentication without modifying the downstream resource. So in both those cases, and this can be applied also to remote desktop or any other key-based protocol, we're able to do two things. Apply identity to the downstream resource. So the downstream resource here was a Linux server in the first case and a web application in the second case. We're able to apply the identity without installing or configuring anything from the identity provider onto the web application or the Linux server. And we were able to enforce higher level security controls, in this case, multi-factor authentication and just-in-time access without changing the applications at all. The second scenario is the locally stored resources. So again, these are downloaded content, where content is typically a file, could be an email, something like that. And so we're going to show 3 ways of enforcing that concept of I'm no longer an employee, I no longer should have access to this content. How do we stop the end user from accessing something that they've already downloaded? And we haven't revoked their computer. We haven't done anything like that. Now, You could do some sneaky things like have the computer constantly poll a backend system and say, hey, am I allowed to read this? But if the content is already available in plain text format, in other words, it's already decrypted, those controls are really just a layer of obfuscation. What you really need to do is keep the content actually encrypted the whole time and only decrypt it on the fly when there's a valid use to use it. Now, if you do this properly, you can do it in a way where it actually transparently works with existing systems. So we're going to show a way to do it with Outlook for encrypted email. We're going to show a way to do it directly on the file system using Windows encrypted file system. And we're going to show a way to do it with PDF because PDF actually has the built-in capability for this. There's other ways to do it too. You can hook it into other things like Veracrypt and other encrypted content or encrypted file systems. So first up on this one is the email case. Now we're showing an email that is encrypted and signed, and the second email is just signed. So the first email has sensitive data in it. So we're going to say that employee is no longer an employee here. We want to revoke their access to sensitive email. We disable the key, and immediately we can no longer read the email, effective immediately. And so even if we double click on it, can't read it. So now if we go back and say, never mind, we extended that employee's contract, let's give him access to his email again, immediately we can do that too, and we're back in business. So by proxying that key to decrypt, we're able to enforce that policy in real time. Now, these other ones are going to be exactly the same. So this is reading an encrypted file that's on the file system. If we go in and disable that decryption key, by the way, we don't have to disable, we can revoke the user's permission to the key. There's many ways to do that, but we disable it here. Now, if we try to read that file, we're no longer able to decrypt that file, and so we can't read it. And PDF has the exact same capabilities in there. So this PDF is actually encrypted using a certificate. And you'll see it when we first open it, we're able to read it. And you'll also see that the file is in fact encrypted. You can see that there. And so now when we do the exact same thing, we disable that key and we try to read that file, we'll no longer be able to read the file. So these are just various layers of applying the same concept to various forms of resources. And you can pick what makes sense for your enterprise, or you can use them all. They kind of all follow the same exact pattern of doing things. Now, that last comment I made about following the same pattern, how do you make this actually work in an enterprise system, right? So we showed some demos that's nice on a single use case. How do you make this scalable across the enterprise? So there's two components to it. One is, where do you keep the keys, right? So maybe you're in the cloud, maybe you're on premise, maybe you hybrid. There's various places to keep your keys. So the cloud providers provide KMS options, AWS KMS, Azure Key Vault, et cetera. On premise, there's some great solutions from Talus and Entrust using the Luna HSM or the Enshield HSM or the Cipher Trust Manager. There's all kinds of options. HashiCorp has HashiCorp Vault, and there's other ones too. So figuring out what works there, you may very realistically find if you're a large enterprise that you're going to need multiple ones of those. So you're going to need to support multiple types of key management systems simultaneously. And then how do you integrate it now with your clients, right? So how do you make it just work on my laptop without changing the tools that I use today? So if you'll notice in the videos that we showed, we were using standard tools. We did the SSH demo with WinSCP. The PDF demo was using a standard PDF client, Outlook. Those are all standard clients. So you want to make sure that you can continue to use standard clients today and be unaffected, as opposed to uprooting my tools and forcing me to use new tools. And the way you do that is you provide cryptographic API implementations. So all major operating systems, tools, they support cryptographic APIs to offload cryptographic processing. Now that's all fun jargon just to say they provide hooks so that you can continue to use the tools you use today to make these things work, regardless of where your keys are stored, regardless of your identity provider. And you can do that all behind the scenes. So on Windows, there's a cryptographic API called CNG, stands for Crypto Next Generation. Typically, an implementation is referred to as a KSP or a CSP. Mac has the CTK, crypto token kit, etc. So as long as you have these various implementations of those cryptographic APIs, and then you can use that to talk to your backend key management system, you have the tools you need to deploy that enterprise-wide. So you just need a cryptographic API implementation that talks to your identity provider and then talks to your key management system. And then you'll get all those benefits of what we showed in those videos transparently or seamlessly. So the summary of the benefits of this approach, first and foremost, you're able to apply the digital identity to all enterprise resources, not just web applications. So we can now apply it to across the board, SSH, source code repositories, et cetera. And we can even apply it to content that's been downloaded, which I think is one of the more interesting things. So even to files I've already downloaded and you want to revoke my access in the future. We can also enforce granular controls without modifying applications or servers. If you have 5 applications or servers in your enterprise, maybe it's not a big deal. But if you have 1,000, if you have things in the cloud, on premise, and it's sort of a scattered, very big smorgasbord of resources you need to protect, this starts to become a lot more valuable to an enterprise like that. You get full visibility and centralized auditing. You get that anyway with your identity system, but now it's that applied to all resources as opposed to just a few. And then simplified key management that really buys a lot of compliance for a lot of uses. So by showing that, hey, for all use cases, my keys are centrally managed. I can see every time they're used. I can enforce policy on how they're used in real time. That's going to really make life simple when you need to prove to an auditor how you're compliant for various compliance purposes. Of course, we were using a particular implementation of this for our demonstration videos, Garantir. It is our product from Garantir that does exactly this. So Garantir does integrate with the backend key management systems from the cloud providers, as well as the on-premise ones from Talus and Trust, HashiCorp, et cetera. And we do provide all the cryptographic API implementations to make this work out the box. So you can do exactly what you were seeing in the video across in your enterprise in a very scalable manner, and you can apply it to a lot of use cases for identity management, basic things like we showed, and even some more ones that are less commonly talked about, but like applying it to code signing systems, document signing, things like that too. So that was a presentation on that subject matter. Let me see if there's any questions. So I see a good question about how to improve the performance for API calls. It's a great question. So this gets a little technical. There's a few things that are done. The first one is that we do something called client-side hashing. So what you have to understand, underneath the hood, these authentication protocols are all doing what's called a challenge response handshake. And that means the end resource issues a challenge, and then you have to sign that challenge and send it back. What we do in Garantir is we do client-side hashing, which means the digital signature we break down into 2 components. First, the hash, then the private key operation. By doing the hash on the client side, we make sure that the data sent over the network is extremely small, and we're able to go blazing fast as a result. So no matter what the size of the data we're signing is, we always fix it to a very small length, roughly about 256 bits plus some metadata. And so we're able to go extremely fast. We also do a lot of caching. So cache connections to the KMS on the back end. You make use of TLS 1.3's very performance capabilities. There's a lot of other things that happen there too. But the main thing is the client-side hashing. And then for the encryption stuff, for encrypting content that remains on disk, we actually use envelope encryption. You can see the cloud providers talk about that a lot. By using envelope encryption, you're able to effectively do a similar thing as the client-side hashing, where the data sent over the networks to a minimum. And what that really means is you're encrypting the content with a data encryption key, and then you encrypt that data encryption key with a master key And that master key is what's stored on the backend system and has the policy applied to it. And it unwraps the data encryption key. And so what the net effect of that is if you're, let's say that PDF we did the demonstration on, let's say that was a 3 GB file, a very large one. It's still, the data sent over the network would be fixed in length because we would just be decrypting that data encryption key. So good question. Another question, let's see, how can we ensure the security of a centralized management system? That's a great question. So first and foremost, of course, obvious security approaches apply, right? You want to keep this thing very isolated from the rest of the network and just provide a very secured interface to it. There are some other things you can do on the back end. You can do key splitting, key wrapping. I unfortunately will run out of time before we can go over how all that works, but there are ways to make it so that even if someone runs away with the back end key management system, you still wouldn't be able to use those keys because you did some key splits and things like that. Happy to discuss that further if anyone wants to shoot me an email or something, but there are ways to do key splitting, and of course, just standard locking down that interface to that key management system. There's also, on the aspect of security, typically people are talking about confidentiality and integrity of the key management system. There's also the availability question, right? So when we now have a proxied system, which effectively is controlling your access to downstream resources, how do we ensure the availability of that system? Because if that goes down, does that mean I can't access all the other systems? And by default, the answer would be yes. So obvious answer, the first part is, we do everything with the high availability deployment. So, standard high availability answer there. But beyond that, you can also deploy the system with a break glass sort of way. So that worst case scenario, let's say you just couldn't get your security orchestration system, or in our case, Garantir back up. We've never had that happen, but let's say that scenario arose. You can do it where you could still go in, break glass, get those keys out, and distribute them out to end users to use. But the real answer is having a high availability, sort of geographically dispersed system that can support all this. It's very doable. And we, of course, have customers that do that. So, Brian, that's great questions. I appreciate you having me here to talk about this topic. I'm going to pass it back to you with, looks like 2 minutes to spare.